Okay, so you're going to have this little window, and you will need to use the username and password there. When you open it, you are going to request to enter the username and the password that you receive. So this is the first step. And we need to create a new model. So I need to click here. This is new model. And then here in microscopic letters, it's going to ask me, I think this software was designed uh, for big screens. And this screen is a bit blurry. Yes. So which unit do you use? Usually length meters, mass kilograms, energy we don't need joules. John Molos, I will use megapascals, force newtons, and temperature we don't use. So you have to choose the units that you want. You have a preset like international systems, whatever. So the first step is to choose the units of that you are going to use. Uh-huh. Okay. Then you need, so we are going to solve a problem. So the problem that suggests me Peter is, we are going to solve a problem of, let's see. Okay, it's recording there. The problem of propagation in a rectangular domain with two layers. This is one material, one soil, another soil. So we are going to fix this here. And we are trying to model a large system that is very tricky in wave propagations. And here at the top, we are going to apply excitations. So we are going to produce a wave here in the middle. So I need to create a rectangle. So to create a rectangle, the cheapest way is to use snap to grid. Here we have a predefined grid that you see here now, a few points in the grid, but it's not showing all the points. You have to press F3. F3. Press F3. So you know what is F3 here? F3 is here. Yes, F3 is refreshing it refresh always the screen. So this grid will allow you to start building the model. So this is the grid. So you want to see what is the values of this grid point, you have to hover over the grid points. You can press shift and hover. For example, this one is going to be 0, 0, 0. And this one here is going to be 15, 15, 0. So it means with this grid, we can create a domain of 15 meters large. Yes. But probably you want to have a bigger model. So you can go to the grid here.
Can you maximize the screen maybe?
Yes, I will try to maximize because it's very, very difficult to see.
From there.
Yes, the maximal. Okay, no, I can go to the grid here. This is the view options here, all the view options. In the grid, I need to press left part of the mouse. Where is the left part? Yes, left part of the mouse. And I can choose here how I want the grid. I have 15 by 15, but I'm going to model from 0 to 50 meters. 50 meters. 50 meters, okay. And again is F3, Fn, F3, F3. So now if you go here, this one is going to be 50 meters. So this is the grid. Now I'm going to create the elements, and I'm going to create two elements. There is quad 4 elements. So to create elements, you have to use, so here there are the general options. Global insert. Insert is to insert an element. So let's see, insert. Insert an element. Yes, I'm going to insert element, and I have options of the elements. So this is the linear elements, pin 2, pin 3, the triangular elements, but the one that I want to use now is quad 4. That is a quadrilateral element. Yes. And then I can create elements using the grid. Click here, click here, click here, click here, and this is one. And I am going to create the other one using the same counterclockwise. So from here to here to here to here. So I create two elements. Yes. Now I don't need the grid anymore. And maybe I can make the nodes a little bit bigger because I cannot see them. Let me see. Let me make it bigger. So how I did it? So every time I want to change something in the view, I need to use these tabs, these ones, and for this one I click left click, and it give me the options. I just wanted to make the nodes bigger so I can see them. Yeah, so you can see two elements and the nodes. If you want to know how many elements, you can go here. How many elements do we have in the model? So you can see here that we have 6 nodes, no beams, and 2 plates. Plates is the generical term from two-dimensional elements. If it's 3D, it's called, I don't remember what is the name of the 3D. Bricks, probably bricks. So plates is 2D. Yes, here is brick. Brick is 3D. Beam is 1D elements. And vertices and face we are going to see next week because they're related with the model, the CAD model, computerized design models, the geometry. So we have two elements here, but we wanted this element to have different material properties. And yes, the model create all this with undefined material properties. So I'm going to create the material properties. So to create the material property, I have to go global and then properties. Properties. There is no material properties at the moment. No, because it's beam. So one property is in the plate. So I have to click here, plate. Plate property, the blue one is unknown. I'm going to create a new material property that is called clay. And I'm going to make it soft, 10 megapascals. And use the Poisson ratio that Peter recommended me, 0.25. Yes, and the density is going to be 2.4, 2400 newtons over cubic meters. Okay. Yes. Okay, this is for the clay. And is the element marked in blue is going to be clay. I can change the color here. eh, Yellow. Okay. Okay, and I'm going to create another property. So I can click here, plus, plus, plus. No, this is delete. A new property. Create new property, this one. Uh, let's call this soil. Soil. Um, let's make it a bit stiffer, 20 megapascals. Poison ratio 0.25. And the density, I'm going to use the same, 2400. Uh-huh. Okay, so maybe we have to give a thickness to this one, because if I don't give it thickness, the code will complain later. So I'm going to put 1 meter for the moment of the thickness. This is the thickness perpendicular to the screen, and here thickness is 1, 2. So two properties, clay, so clay and soil, and I only need to specify the material parameters. Yung módulos puede ser un ratio and density for this kind of modeling, and the thickness of the plates. I don't need to specify non-linear. I don't put anything in damping, so only these two options. These create the properties, and I'm going to close this one. Now I have to assign the properties to the elements. So the top one is going to be clay, but this one is going to be, this element is going to be soil. So to change the properties of the elements, I need to first select this element. The selection options are here. All these options here is to select. Okay, let me see. Select. You have this icon is to choose the way you want to select. The default option is invert selection mode, but you can click always select or always clear the selections. So this is the default one. And I want to select the elements. I can select here the vertex, no, sorry, the nodes, the beam, the plates, or the bricks. So I want to select plates. Select or unselect plates. This option tells me that if select, I'm going to unselect, and if unselect, it's going to be selected. And this option tells me that I'm going to select plate. So I'm going to select this plate here. Uh-oh, it didn't select it. Let me see. It's still not selected. What happened? So maybe I didn't do. It's refusing to select. Let me always select. So if it's selected, it should be appear here, plate. Oh, now it rotates. I don't want to rotate. To put back in the view positions, you have to go here, view angles, and then you have to use XY. But I'm trying to select the plate, and I don't know why I cannot select here. Always select mode. This is strange. This has not happened me before. Select, undo. This is clear our selections. Select by two direction. Let's try with this one. And now I select, okay, now I select the nodes. So I select the nodes by regions, but I don't want to select the nodes, so I'm going to clear the selections. So I want to select not the node, but the element. So I need to click here, that is select, place select, and then I'm going to select by region here. And then I think one was selected. If you are not sure, so here you see two plates and all have been selected. Okay, no, this is not correct. Probably I need to unselect this one because I selected before. So how can I unselect this one? So I need to go here, always select, always select mode, always select invert selection mode, for example, this one. Yes. Okay, let me see how many plates are selected. No, none of them is selected. So annoying. One plate is selected. Okay, so let's go to attributes, plate, and I'm going to property type. And then I'm going to give the property type that is plate property 2, apply. Okay, this is the first step. So we have two elements. One element is clay, and another element is rock. Okay, so the next step, what is the next step? Is to put the boundary conditions. So the boundary conditions, we are going to fix the nodes at the buttons, and we are going to put some boundary conditions in the side nodes. So first, let's fix the nodes at the bottom. So I'm going to select, go to select again, select nodes. This one and this one. So I select two nodes. You can see here that two nodes have been selected, and I'm going to fix them. So to fix them, you have to go to attributes, and then you go to nodes, restrain. And we are going to, there are options to restrain the different degrees of freedom. We are going to fix all the nodes. Not all the nodes, all the degrees of freedom of the nodes. All the positions and all the rotations will be fixed. Apply. So in principle, all the nodes have 6 degrees of freedom, 3 rotations and 3 translations. I have fixed everything here. For this node, I'm going to apply boundary conditions too. I'm going to select them. And then I am going to apply boundary conditions. So it's going to be, which boundary conditions? I think X symmetry. So let's see what is X symmetry. So here, you cannot see here, but X and Y, X is the coordinate, the horizontal axis is X. So I'm going to use X symmetry. X symmetry. So it means that X will be free. X symmetry, X will be free. No, I want to fix X equal, what is the boundary conditions here? So I wanted to fix, allow the movement in Y, and I need to restrict the movement in X. This I don't care very much. Fix everything, but no, free everything, but I'm going to fix in X only. All right, let's fix this one. We can deal with this rotational later, but I'm going to fix only in X. In X. 4 nodes. Let me check that there's 4 nodes. 4 nodes are going to fix in X. Okay. You want to know if the boundary condition is correct, you can go hover over the node and click shift, and you are going to see what is the attributes of this node. This node is 0, 50, 0 coordinates, is restrained in is restrained, and you fix the x and the rotations. Talking about the rotations, this problem doesn't have node rotations, and I'm going to fix it globally. One way to fix globally the rotation is going back to the different ways to fix these rotations. You can go to properties and materials. Yes, here. You can see here plate shell. This is not a plate. This is a plane strain element. Plane strain means that the deformation is going to be only on the plane for the clay and for the rock. So I put these conditions so the deformation will be only on the plane. Okay, so we put the boundary conditions, but we need to apply the laws here in the top. But to apply the laws, we need to subdivide these these elements. So at the moment we have only 2 elements. It is convenient to apply the boundary conditions when you have very few elements, because you need to do less clicks, so it's easy to select the nodes. And after the subdivisions, you will see that the boundary conditions will be replicated in the new nodes. So let's subdivide these two. I'm going to select all the elements. There are only 2. Select select 2. Let me see. Select all. And I'm going to subdivide them. Tools. Subdivide. Mesh. So here in tools is whatever you want to do in the model is in tools. I want to do some changes in the mesh here, and I am going to subdivide, and you can see here A and B. Here is A and B. The directions here A and B, and I can subdivide, for example, in 8 by 8. Yes, here there is one detail. So for infinite element analysis, you want to make the elements as square as possible, because the error in the error in the finite element solutions increase when the elements are distorted. So you see that this element is it's not very square, so especially the top elements. So I'm going to go back, and I'm going to change A by 10, apply. No. Yes, more square. Okay, the more square. You can subdivide the two regions in the different way. This top region and the top regions. But it's very important in finite element analysis to check that all the nodes are connected. The nodes of this region need to be connected with nodes in these regions. If they are disconnected, MATLAB will, no, Strand7 will interpret this as a gap, as a crack, and the solution is not going to be, is not going to have any meaning. To check that the node is connected, there is an option here that is utility. No, it's not utility. Detect plate edges. Where is the plate edges? I don't see them. Okay, I need to click here, okay. And I close this one. Here are the edges. So the edges of the plates are outside. If I have an edge here, it means that the nodes are not well connected. But there is a problem here. I can see that there is a problem here. I don't know why I have this problem. These nodes are fixed. These nodes have a boundary condition that I didn't apply. So this needs to be fixed. Yeah, so let's go back to detect case. Detect. Okay, remove. I don't know why all these nodes are, something happened during the subdivisions, but this doesn't look very good. Let me see so I'm going to check the boundary conditions here, the restraint. So this one, more this, yes, I need to click here. So this one got fixed. I don't know when this got fixed. These ones. So they are selected? No, not selected. I need to select them and remove, or maybe I can go back. Okay, I'm here. Yes. Yes, I think. Okay, so yes, I think this knows. Yes, I think I need to do something different. Yes. When I subdivide, the nodes here inherited the boundary conditions from here. That is not what I wanted. Yes, I need to fix this problem. Yes, so I'm going to subdivide this step by step. First, I need to select them, select all, and I'm going to subdivide again. Tools, tools, mesh, subdivide, and then I'm going to subdivide 2 by 1. In the A, I'm going to subdivide by 2. In B, it's going to be 1. Apply. And then let's check out the elements, what happened with the elements. So I need to remove these boundary conditions here of these nodes, but I need to select these nodes. I'm going to select these three nodes. Let me check if they are selected. Not yet. So one, two, three. So three selected, and then going to be attributes, node, restraint, and I'm going to free them once. Free these three, apply. Okay, now they are free. Ah, but this one, no, one moment. The bottom one. Okay, better. Okay, now I can subdivide them. Uh, Select all. Let me see if I can put control O. No, control all doesn't work. So I'm going to select here the plates, control all, and then I'm going to subdivide them. Subdivide tools, mesh, subdivide. Let me see in B. A, A, 4, 3, 4, 5, 6. Let me try with this one. Yes. Okay, the subdivisions. Okay, so I think the boundary conditions are well. Yes. Apply. Okay. So where I'm going to apply the load? I want to apply the load, the excitations at the top. I want to make this in the middle. What is the middle? Middle is here. So if I put this in the middle, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the middle? This is the middle one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I want to find the middle one, but there is no middle one. Let me see if I make another subdivisions. Subdivisions. Tool subdivide. Trying to copy. I don't remember if I. Okay, here. A. No, I cannot divide this because I started from this way. Yes. Oh, I'm going to put. So I will put the excitations as close to the center as possible. Here I'm going to put the excitations for. There are very different ways to put the excitations. I'm going to apply the simplest one, that is apply a load in this element. I'm going to put a load in this edge of this element. So I'm going to do tools. No, attributes, plate, phase H load. Where is the H load? Normal pressure. I need to choose the element. The element is this one. I'm not sure if I'm selecting this one. One plate, yes. But I need to choose the edge where I want to apply the pressure. So I'm going to invert selection mode because I think no. I think the problem that I have is that I don't have a proper mouse. I don't know what is click here. Oh, jeez. Okay, let's see. So I'm going to put here 1 megapascals. No, it's so big. 0.01 megapascals. And where is it applied? It's applied here. I don't know if it's applying in the other nodes but we can check this in another way. So we can check in the text here, and we have all the data. If you click, this is the visualization of the problem, and this is the text of the problem. And here I can see the nodes, or I can see the plates. In the plates, I want to see where do I apply the normal pressure. I apply the normal pressure at a plate 0, and the H3 of the plate, and this is the value. Yes, I think it's correct. I only have pressure applied in one of the plates, not one edge of one of the plates. The plate ID is 0. But I don't have a plate with ID 0. The ID starts from 1. This is the plate 4. Okay, I don't know what is the plate. Is it plate 4? Yes, we need to check what is the plate for to make sure that we are applying the load in the proper place. So I need to click here, and check shift and hover in the plate. So I am clicking here, right? And here we have to read what we have here. So this is the quad 4, plate 4, quad 4, have property 1, have 4 nodes, and have normal pressure of 0.01 megapascals in the H3. So I think it's correct. The only problem is probably we need to change the pressure to negative value. So we can go to text and go to the plates and go to the normal pressure, and the value is going to be minus 0.01. Okay. Okay, let's fix the view. It's going to be XY plane. Okay. Okay. So the next step, what can I do now? So you can see that the pressure is going towards the plate. Mm. We put material properties, boundary conditions, we apply a stress. Just to check that everything is okay, I'm going to run the static solvers to find the static solution for this problem. And to find the static solution, we have to go to solvers. Solvers. And Strand7 have different solvers. The simplest one is linear static. So the linear static is selected here. Just click solve. And we need to save this one. This is by layer. Uh-huh. Okay. I forgot to mention that you have to look what you have to read the log. Yes, here. So you always wanted 0 nodes, 0 warning, and 0 errors. If this happens, maybe the solutions run well. So I think everything is correct. I'm going to look at the results. To look at the results, you have to click here. This is the open, close results. And is the linear static analysis, click here. You don't see nothing here. So I'm going to click here in results. But we are going to see the contour of the stress, for example, contour of the stress, the combined formations stress, the most common one, apply. Oh, this is the stress. So the stress is applied here, so it's expected that the stress is concentrated here. Uh-huh. I can look at the deformations, results, displacement scale. These buttons, it's not clear what is this ones. This is 5% of the deformations, or 5% of the, I never know what is this exactly, but you click here, you can see the deformations at different magnifications. So the deformation looks okay. So it's deforming when you apply the load. You can also plot the results. You can plot the stress along. You can plot versus positions, or you can plot the stress versus positions. Let's plot. No, I don't have the stress here. Here, only displacement of reactions. Let's see. I think I missed something. Results. Click results, graph. BS versus positions. Okay. Quantity. Where is the stress? Entity plate, because yes, I need to click plate because the nose doesn't have the stress. The stress is calculated in the plate. And then I calculate the stress, the formices stress. Okay. I need to specify the points. I'm going to choose position. I need to choose 2 points, for example, between this point and this point. No, I didn't choose the points. The same, something with the mouse, because if I have a proper mouse, I should be able to click here. But how can I click this one? Let me see. Here there is a mouse. There is a mouse. Okay.
No. You
Mhm. Okay, yes. No, the mouse is not working. How can I click here? You just need to do a simple click, but it's you wanted to rotate, not to click. You see, you rotate. Should be an option here. Okay, so what time this course finish?
it's already there.
Okay, yes, I think we have to finish here. And I think next time maybe we have to go to my office because in my office I have a big screen. Here it's very difficult to do the modeling with such small letters. So, so this is the static analysis. So, where were the questions?
Is it possible to upload a file like say a velocity file in Excel or
Velocity file?
yeah,
Yes, you want to do the initial velocity, right?
like I have a velocity file already based on my problem
Uh-huh.
and my and the the density.
Hmm.
If I have the density and the velocity in Excel format, can I just import?
Yeah, you can import in here. When you using text,
Okay, yeah, exactly.
you have import, yes. Also can import tables like layout. You can put, for example, velocity versus time. You will need to create a new table and you can input the data or you can input the formulas. So I think, I don't know, I probably I will ask Peter if I can teach on Wednesday because I didn't finish this part.